Good morning, good afternoon, or good evening, depending on when you're watching this. So what are we doing today? We're still doing three Venn diagram example, but today we're going to introduce a slightly uh, complicated element to it. So what does that mean? First, let's unpack our scenario because I have it all here, but if you're watching this, you probably don't know what the scenario is. So the scenario is that grade 11s from a school called Freedom School make use of public transport, right? There are three available modes of public transports. There are buses, which are called Event B, right? There are minibus taxis, which are called Event M, and there are trains. So there are 100 grade 11 students. There's my sample size, right? And what other information are we given? So we're given that 29 students use buses. So B is 29. We're told that 62 students use the minibus taxis. So that's 62 there. And we're told that 40 students use trains, right? What else are we told? We're told that 12 students use the bus and the minibus taxis. There we have it there. We're told again that 22 students use the bus and the trains. There we have the value there. And lastly, we're told that there's 17 students that use the minibuses and the trains. And then obviously we're told 13 students don't use any public transport. So probably their parents drive them to school. So number one, we asked to draw a Venn diagram representing this information and let the intersection where B intersects with M intersects with T be equal to X. So that's what we told in the first question. That's what we asked to do. So let's do that. A, draw my Venn diagram. Right? That's my buses. That's my mini buses. And that's my trains. Right? Label them buses, mini buses, and trains. So I can already fill in the information of people that don't use it, which is 13, right? So here we're told this is X. And so we're told to answer this question and write everything in terms of that X, right? So think about it. This B intersecting with M is this whole space right there. So what would this space be? The I. I'll call it I there. I is equal to 12 minus X. That's what this space is. 12 minus X. You get it? And so, what else am I given? B intersecting with train. So there we go. This space right here, I'll call it number 2. That space right there is just 22 minus X. So I'll put it there as well. 22 minus X. This space right here, where the minibuses and the trains intersect, we told that whole space. So if I'm trying to find just this small space right here, I'll take the total, the 17, minus the X. So this is just 17 subtracted by x, right? Then let's work. Let's go to the B and the train and the minibuses. So we told the whole space here. How many students use buses? How many of those students use buses, right? But we're not told how many use only buses. So we need to write that in terms of x. So I'll call, let me just do number 3 first. The 17 minus x. So number 4 is the space right here, is equal to 29, the total space, minus 12 minus x, put it in brackets like that, right? Minus the x minus this, the 22 minus x. And so what does this equal to? 29 minus 12 minus 22 gives us minus 5. Positive x minus x cancels the x, but I have another positive x. So this is negative 5x, negative 5 plus x. Excuse me. And then this space right here, which I'll call 5, is equal to the total number of that space minus these areas that are already filled in. So I'll say 62 minus 12 minus x minus 17 minus x. What does that give us? 62 subtracted by 12 subtracted by 17 gives us 33 plus x, because that gives us a positive x. Subtracted by that x, it cancels. That and that gives us a positive x. So this area right here is 33 plus x. We left with that small area there. So that area I'll call VI, which is 6. I take the total trains, the total people that use trains or students that use trains, minus the ones that use trains and minibuses, the ones that use trains, minibuses, and buses, and the ones that use trains and buses. And what do we get? 40 minus 22 minus 70. I get 1. So it's basically 1 plus x. So there we go. We kind of answered the first question. Everything is in terms of x, right? And guess what the second question asks from us? B asks for us to solve what this x value is. So let me just erase all those calculations here. So B, we asked to solve for what that x value is. How we're going to go about doing it is we need to add all these, right? And all of them will be equal to 100. And then solve that equation. So let me do it. I'll say negative 5 plus x plus that space there, 12 minus x plus that space there, 33 plus x, then that space there, 22 minus x, add that space there, just x, add that space there, and then lastly at the 13, the ones that don't use public transport, and all of this will give us 100 students, right? It's a long equation. Most of these are going to cancel, so we have an x and a minus x, they both cancel. X and a minus x, they both cancel. X and a minus x, they both cancel. So what I'm left with is just x. So I'll put x there. And what I need to do now is I need to add all the numbers: -5, 12, 33, 22, 17, 1, and 13. 33, 22, 17, 1, and 13. I get 93. So there we have it. It's much simpler now. You subtract by 93 this side, you subtract by 93 that side. You get 100 minus 93. And x is just equal to 7. So there we go. We solve for B. We solve for A as well. So what does C want from us? C wants us to solve for the probabilities. So let's just erase all of this. Alright. Let's just write what the x value is. C asks us to find if a student is chosen at random, determine the probability that the learner uses a bus and minibuses but not trains. So there is bus and minibuses but not trains. Still, they're speaking about that area there. So that area is just 12 minus x divided by the total sample, which is 100. 12 minus x, the x is 7, so it's 12 minus 7 over 100, and this is just 5 over 100, which is 5%, right? Number 2 of C, we're asked to find the probability that the learner uses only one mode of public transport. One mode of public transport is that guy, and that guy. So you add all of those things. It's -5 plus x plus 33 plus x. Or let me just go with 7 already, because I already know what my x is. So let me just substitute 7 then to cut me some calculation time. Over 100. Remember, it's probabilities, so it's going to be over the total sample space or sample size. 3 plus 7 plus 1 plus 7. So this is a half, which is 50%. So 50% of people use only one mode of transport. So the last one, what is the probability that the person uses one or uses more than one mode of transport? So that's 1 and more than 1. We're talking about that space, and that space, and that last space there. So we add all those values. So it will be 12 minus 7 plus 17 minus 7 plus 22 minus 7 plus the 7. We need to add this area as well, where the person uses both minibuses, trains, and buses. So we add that area as well. Divided by 100. What do we get? We get 37%. This is 37 over 100, which is about 37%. So there we go. So let me just run you through it again. So this question was different from the first one I did in my first video, because now we had an unknown. This area where B intersects with M intersects with T was unknown. So I had to call it X, and I still worked my way outside. So from the inside out, 12 minus X, 22 minus X, and 17 minus X, right? Inevitably, I ended up with that area and that area and that area. That area was already given. So you needed to add all of these figures with that figure to get 100 to solve for that X value. So that's the only significant difference here. Thank you.